The talk today is going to go in three major sections. Well, four, according to the little outline here. I'm going to describe at first the underlying technology so you understand what the product is that we're dealing with. Secondly, we're going to talk about making functional tests, and most importantly, I'm going to talk about how eValid is able to handle and deal with all of the really crazy things that happen with AJAX. So they're crazy good things that happen with AJAX, but they're crazy wild and weird if you're trying to build functional tests of these kinds of applications where there's a dynamical interaction between the browser and servers where you don't even know where they are. The next phase, we'll talk about monitoring, some basic principles of monitoring, and we have a demo we'll show you of how eValid scripts are playing back and producing timely reports and confirming quality. And then lastly, the third part, we're going to illustrate eValid's capabilities of taking a functional test, lifting that functional test into dozens or hundreds or thousands or tens of thousands of browser users. Our demo will show just 100 because the screens get a little bit busy beyond that. But we'll do a demonstration where you see 100 simultaneous browsers running on one desktop. So, underlying technology. The product that you see on your screen, which I've got showing the Bing search engine, this is the eValid product. This is a Windows desktop product, which is a complete browser. I can go back to where we were, forward. It has view, the usual kinds of things, a whole bunch of favorites, tools. But the browser that we've built is based on the Trident rendering engine. That's a fancy name for it. I'll give you the C++ class name. It's called iHTML Document 2, or Web Browser Control. It's an ActiveX control that's derived, that's delivered via the DLLs that are incorporated in the IE browser. So, for example, in this case, we're on IE, we're on Windows XP. Sorry, I want to show the other one. System information, we're running on IE version 7. eValid will also work just fine on 8, and we've recently confirmed that it works on 9. The magic thing we did, if there is some magic, is that we didn't build a browser from the ground up. We built the browser outside, the container, so that we could achieve what I consider here a complete web testing solution. The correct way to think of eValid is this, a very simple phrase: test-enabled web browser. Now, the browser is 100% equivalent to what the IE browser does, but it's not IE. It's an IE clone. It's about 99.99%. By building our own browser, then, as a functional testing or regression engine, as a monitor engine, and as a mechanism for running multiple browser users in load test mode, we are assured that the response that you get from the user, which is the browser face, is 100% accurate. Now, I'm going to say that it's a self-contained desktop app, and it's low overhead, highly efficient, but most important these days, because there are some other products that do functional testing using the JavaScript APIs, eValid does not, repeat, does not use the JavaScript engine at all. And this is crucially important if you're testing an AJAX application because, well, just stop and reflect. The way the browser works with AJAX is that there are JavaScript programs or ECMAScript programs that are running in the browser right here, right in this browser. They're running in there and they're interacting with the server, as I'll show you an example of this. If you build a test engine that interferes with or operates in contention with the JavaScript engine, then two bad things happen. Number one, your AJAX program probably won't work normally, and number two, your tests won't work normally. So this is a very important issue, that there's no JavaScript interference. And we get a lot of tech support questions saying, well, how do you know that's really true? And the answer is, we've been using this browser for close to 5 years now. It works, it runs every application you can ever imagine just fine. From the point of view of being what we like to consider to be a complete QA solution in a box, we can equip an entire QA department with a floating license of eValid. There's a batch mode interface for regression support. We do package a thing called EV Manager. I won't talk about that today, but it's a simple interface to capture scripts and drop them into a tree structure and run them through the batch mode interface. For everybody's for clarity and for simplicity, remember the KISS rule, K-I-S-S, keep it stupidly simple. We've incorporated all of the inputs and outputs as flat files. Nothing complicated, no structural, just simple flat files. We don't need any more. And the key thing is that as a result of this, programming skill is not required. Okay. Now, to begin with, functional tests are always a crystallization, a capsulization, a quick freeze, if you will, a quick freeze of a human's actions. So here is the browser, and I'm going to show you how you do this with point and click. So this is a record play paradigm. I know there's a lot of static that you get in the universe about record play, but we've made record play pretty much easy to use. So I'm going to start a recording. I'll call it demo. And what happens is that eValid creates a script, and you can see as I type into the script the look-ahead feature. I'm going to skip playing with the look-ahead feature. We've got an example of that later. I'm just going to go look for lucky sevens and see what I find. And sure enough, the eValid browser goes to that page. Whoops. And I'm going to now highlight just one phrase, a community. I'm going to use the record, validate, and synchronize on text string. Okay, that's going to be the end of the recording. Now let's look at the recording we got and discuss a little bit about how that got done. This is, as you can see, if even I can make a recording, why heck, any of you should be able to. And it does get a little bit more complicated than just doing this, but fundamentally it's very, very easy to use. The recording uses internal information about the browser. So if I look at the recording, okay, we recorded in the eValid script. Let me just edit this so you can see it a little bit better. As a matter of fact, I've got font size 2 in there. I'm going to take that out just so I stay with my standard font size. And I'm going to write that script back. You can see there's the ASCII file, and I've just shown an edit. The init link is Bing. We wait 1400 milliseconds. All times in eValid are measured in milliseconds, and the timer resolution is 1 part in 1,000. That is 1 millisecond resolution. And so I type in an input. Now, eValid has recorded some numbers like these things right in here, which eValid has extracted from the actual page. Now, the actual page has a document object model. I'm going to quickly go over the deep end here, but let me show you what happens if I bring up the page map and click on this phrase, a community about. Then the page map, if I get it to the right place, let me show you. The page map is looking inside the page that the Bing website delivered to my browser, which is eValid. And so there's the phrase that's actually rendered on the web page. And eValid, as you can see, has access to the DOM. I'll turn that off. I don't want to overload you. So eValid has picked up this data from the DOM. It uses this data at playback time to overcome the fundamental limitation of functional tests by record play, in that there's a feature called adaptive playback. If at playback time things aren't the same as when you made a recording, eValid says, something's wrong here. Let's stab around on the page and see if we can find out what is a good match. Now, you can't make this, these algorithms are very carefully tuned to give you a match that makes sense, but not a match that always makes your test pass, because if your test always passes, it's no use, it's not useful. So adaptive playback will come into play and save tests from the fate of most conventional record play systems in that the tests are too brittle. So let's play this back and watch what happens. And let me bring up the playback. You can see we go through the steps here. There's the input. We wait for the form, wait another few seconds, and then we're going to sync on that text. And we get back a yellow screen. Now I'm going to not look at every one of these files. I'm just going to look at the event log to see if I can figure out what caused Now, I'm showing you a lot here, so let me go up here and wait till your screen stabilizes. Okay, your screen is now seeing the right thing. The warning here is that the element at 80 isn't the same as during recording. It moves around. It's a function of time. So eValid says, I can't find an SB form go on 80, but I'll find it at 65. I'll click it. Now, there's a risk here that the phrase SB submit form question, I guess I'm guessing the meaning of that, that phrase attached to an element in the page could mean something else, but we've had enough experience with this that if the ID tag, and that's an ID tag of a page, is that, then pretty much that ID tag is unique in the page. So we have a situation where with adaptive playback we overcome the most common kinds of problems with record play. Now let me switch to, and then let me show you about this log. This log is way more detailed than you can grasp in just one playback, but the key thing is to recognize is there's a cumulative down the page, read the cumulative time, and the elapsed time here was 12.8 seconds, right? So there's a summary at the bottom that shows you how long we took and all of that good stuff. So this playback took 13 seconds. Let me go to a prepared example, because one of the things I've learned about giving these kinds of talks is whatever you do, as quickly as possible, begin to rely on prepared examples, okay? Before going on to the example, let me add some other details just to touch on this. eValid is not operating at the HTTP level, but eValid is able to read the individual download times for every page component, and that's what you're seeing here, where with the detailed timings option turned on, we can measure every component and how long the component that downloaded the thread that downloaded that page component took to play back. There are very many validation modes, several dozens of different modes. We'll just point out that you can even validate particular objects inside the DOM. Now, in AJAX, let me illustrate this with this playback. I've got a new script in here. This is now going to AJAX Pro, and this script is one that we worked out in advance, and I'm now not going to try to record this in real time, but this was recorded some time ago, and you see it running, and this is an example in the AJAX Pro which illustrates HTML controls that are handled with AJAX processing. And at the end of the day, this should give me a yellow screen or a green screen. It gives me a yellow screen, and the reason it gives me a yellow screen again is some adaptive playbacks had to occur. Yellow screens are good. All right. Now, I played this back with the delay multiplier. Now, I'm going to show you something more about eValid that I didn't show you before. There's a whole raft of preferences and settings. In fact, we get a lot of people complaining, well, you have too many options. And, it's like the famous scene in the movie Amadeus where the King of Austria, Ludwig, is it, I think? Franz Joseph. Anyway, he says to Mozart, too many notes. Well, there may be too many options here, but we found in practice that having these options is important. I played with the wait time multiplier set to 0. Set to 1. I'm going to set it to 0 for this playback, and I'm taking the same script, and I'm not going to use wait time synchronizations. Before I play it back, what do you think is going to happen? Well, it's an AJAX application, which is asynchronous connection between the browser and the server. Since there's going to be no wait time and no other form of synchronization, the anticipation is that this test will fail. Okay? And things will go real fast here. Poop, 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 poop. But at the end, the things won't get collected in the right order, I don't think. And I get a red screen. So the red screen says that there were errors in that properties do not match. Well, the message here is important. current selected property E200 does not match that. The reason it doesn't is the browser got ahead of the server. Now remember, there's the internet in the middle. Okay. The internet, variable time. If this was hooked up on a LAN, you probably wouldn't see this phenomenon, but over the internet, you certainly do. And this is, of course, a totally live test. We don't fake any of these things. I'm going to go now to version 2 of this script, in which we added, and there are two things we added. We added a sync on text. That's the same thing that I used in my initial example where I did a synchronization on a phrase in the page. What sync on text does is this. At playback time, eValid waits until the current page contains the phrase HTML controls example. All right, so let's play this back now again with the delayed multiplier still set to 0. And this is exactly the same script, but we added a couple of synchronizations. The first one was to make sure the page shows up, and the second one to make sure that I'll come back to that, a particular element shows up, and we should get a yellow screen. Bingo. We've overcome, with the addition of synchronizations, this script has overcome the fundamental problem of testing AJAX. The AJAX response times vary as a function of the web. I mean, you have a program or programs, multiple threads of programs running in the JavaScript engine on the server, doing the push and pull, interacting with the client. And so what eValid does is overcome this problem by, and let's just see here, if I can find this where we synchronized on that element, we waited for that element. Now we've got the times set inside eValid. There's a synchronization time. I'll be honest, there's a whole set here. We've got the synchronization time set to 100 milliseconds. And this is a fairly quick website. You could choose 100 milliseconds or a half a second, 500 seconds. It depends on the application. There's a slight overhead associated with waiting for synchronization, but we've never really seen that exceed about 1/10 of 1%. So there's a second thing that was done in this script is we did a sync on element property. Now this is a command that was added. This is not recordable from the GUI. But it's simple enough to do that. We're simply we're synchronizing on a page such that the ID equal to CAR, whatever that is. We found that by looking at the page with the page map. And so that particular ID element shows up. Okay. Now, someone I know is going to say, well, okay, that's good. You built synchronization entirely on IDs. What happens if the IDs in a page change? Oh boy! And now we don't build the websites. We just try to test them. And so yes, there are many websites where IDs change dynamically, and after each rebuild, you get a new set of IDs. Well, in this case, we added what are called structural commands. And I'm just going to highlight the commands and not show you in detail how that's done. I'm just going to talk you through. So rather than use this follow link, all right, we replace that with this sequence, which I'm going to highlight, if I can get it highlighted, all right, which says, imagine that there's a thing called the source index inside eValid, and there's an imaginary number. We set that number to 0. Then we search in the page until we find a phrase that says, where the inner text of the DOM says HTML elements inner text is equal to the value HTML elements. Then we do a follow link from that particular DOM element. So that's literally the same as doing this follow link based on element 40. So now, even if the ID tags, now if you leave the follow link command in place, if the ID tag at 40 changes, eValid will search for another matching ID tag. This search doesn't involve an ID tag. It involves an item on the page which is called has a property called inner text with the value HTML controls example. So let me just run this one through, and this has been completely converted now to structural, what we call structural or DOM-based testing, and at this point we don't even get any warnings. I'm guessing that it works successfully. Green screen, not even any warnings. So now you have a test that is very simple. There's a sequence that's involved here. And in the example that I'm using are AJAX forms 2 and 3. The sequence of what we did is we made a recording from life. We modified it for simple synchronization, that is eliminating wait time synchronization. We modified it for page face synchronization, and we further modified it for page DOM content modification. You might say, oh, that's a lot of work. Why would we go to that trouble? Turns out that if you calculate how long it would take you to script this test, what is this thing? This is 60 lines of code. It takes you 5 minutes. That's 3 hours. 300 minutes. That's 5 hours. 5 hours to script that by hand, looking stuff up. If you record from life, I think this recording started at, let's see, it said it started at, it was last June at 16:10, and it finished at 16:10:27. So this recording took less than 20 seconds to make it from life. Less than 20 seconds. And if you count each of those modifications at 5 minutes, you might have invested 15 minutes of people time into a script which is absolutely fully self-synchronized. Okay. So there's we are with AJAX, and we may come back to this example because it's a very nice example. Okay, you can go 2 routes with a test like the one we just created. One, part 3 of the seminar today, you go into loading mode. 2, you can go into monitoring mode, and let's just do monitoring mode first. In monitoring, as everyone is probably aware, everything is all about rich internet application monitoring, that is all about the end user experience. If you use eValid as the monitoring agent, and we have some examples of this in a moment, if you use eValid as the monitoring agent, then there isn't any question about the reality, the validity, and the accuracy of the end user experience. So we give ourselves an A+ score on that. Quality of a web application, particularly a rich internet application, an RIA, including one that involves logins and picking up things and putting them in carts and doing all of that shopping, e-commerce stuff, all of that can be done entirely in the eValid engine. And you use typically a master station which has recording capability and a deployed agent. And reporting is typically done with one of the conventional reporting engines, and I'll show you what that sort of thing looks like. Here is our version of, these are 4 scripts in a demo. Wait till that comes up so you can see it. 4 scripts that are running on one of our machines, driving another one of our machines, which is running groundwork open source, with some extensions. So here is a typical case where you see this, and I won't expect you to read all the words, but you're welcome to log into this. It's available on our website. It's called the monitoring demo, and here is the kind of monitoring information you get. Wait till that all comes up. It's the kind of monitoring information you get with eValid running a playback. I believe these playbacks run at 15-minute intervals. Whaley, is that right? These are 15-minute interval playbacks, right?
Yes.
Yeah, 15-minute intervals. So here's an example of, these are demos obviously, but here is the time that's involved, and that's here in this chart, the time that's involved in individual steps in a playback. Now, this reporting engine can also include, so we're reporting responses. You can also program eValid with alerts and alarms, and so you can have an environment in which the guy in the network operations center can use this kind of a chart to show what's going on. Okay, now I'll come back to that example in a minute. Now, I know that you know there are lots of different kinds of monitoring systems, but I thought that it would be important to emphasize that this particular solution using the eValid browser operates entirely at the user level. So you're really not cheating by using pings or trace routes or HTTP protocol. You're really using You're really using the actual behavior of the browser. Now, the examples we have here don't show this, but I can assert that there are plenty of ways to prepare for what happens when there's an exception, including you can have the monitor send email alerts or alarms or all sorts of other kinds of things. Now, typically, the way we achieve this kind of result, and I'll put this thing back up on the screen, is that we operate the eValid engine from the batch command line using the Windows scheduler. And someone said, why don't you build your own scheduler? We looked at the Windows scheduler. We scratched our heads. It was about a year or 2 years ago. We said, why duplicate something that's so... we aren't going to be able to compete with Microsoft on the design of the scheduler. So it's batch commands running into the scheduler, dropping reports into a log file, and then this particular integration here, let me go back here to this one, this particular integration, say with Google, and I'll show you the page that's involved. Here's the actual script that's involved. This particular integration is a standard eValid script with a couple of things like this, with a elapsed time with a formatted request. That's simply a way of sending a message over to the Nogviz engine. And so that kind of reporting is set up very, very easily. And you get the reports that you see on the screen this way. Now, I'm going to show you another thing that's important about eValid, in that if you're running in monitoring mode, you can run multiple eValid playbacks on one desktop. And let me illustrate how that works by bringing up the little dashboard. And I'm going to minimize my browser. And let me just take this over here off the screen, so there's really no browser on the screen. And this was the test you just watched a minute ago. This is executing with the eValid browser minimized. It's important to understand at this point that eValid is running completely without reference to any screen area. So its footprint is now 0 on the desktop. And the behavior, same identical playback. I'll ask you to believe that that's true. And now, can I bring this back up? I think I can. This one. So you can run eValid minimized, and that's an important reality. While in a moment you're going to see eValid running up to 100 simultaneous browsers, for monitoring mode, we generally recommend a limit of about 10, because you want to allow for the possibility that if a website goes slow or becomes slow, that you don't want one monitor to still be running while the one that's scheduled for the next instance steps on it. So generally speaking, we recommend a limit of 10 or maybe 15 simultaneous browsers. The story is not as pleasant when we're trying to monitor desktop applications. And I see signed up some people in our community of users who are dealing with questions about monitoring desktop applications. And so with desktop applications, there is a unitary resource, and that is the desktop. So eValid, in monitoring a desktop application, must get exclusive control of the desktop and keep exclusive control of the desktop, so that other scripts that might be playing back don't interfere. And there are special commands called lock and unlock in eValid, which lock eValid into the desktop mode and so forth. Okay, so there we are with monitoring. Now, the third part, so we see monitoring. The third part is relatively simple. Whaley, why don't you take over now and talk about the scenario editor and follow this outline, and then you can start your simple playback. Go ahead, Whaley. Hello, Whaley? Yeah.
Okay. Hello, good morning, good afternoon, good evening, everybody. Can you see my screen okay? Should see it.
Yeah, I can see that. Yeah, I see that. No problem.
Have a clear view.
All right.
Yeah, you're live.
For a load scenario, once you've loaded the load test script. It's usually an EVL script. You're presented with your load test scenario editor. And basically this is a lovely little environment which you can add scripts in repetition and provide the necessary parameters in a friendly formatted manner. The equivalent of this load test script in ASCII format appears like this, and basically our script is going to run a 100 wide load tests with one repetition, so we have 100 instructions which are going to invoke the eValid browser 100 times, and we are using the thin version of the engine to lighten the footprint, and we're going to run our test2.evs script. And basically our test2.evs script is a simple scenario which goes to Google, waits to synchronize on a timing page, and then goes to our website to download a 100 kilobyte ASCII text HTML file.
And then disappears.
Right.
Right.
So let me go back to our load test. And I'm going to close the load test scenario for now since we don't require it to run. And I'm going to simply click Go. Say no to this. And it's going to take about a minute or two for each of the browsers to ramp up, and once I get 100 iconified browsers in my toolbar here on the bottom, or taskbar on the bottom here, I'm going to place them on my desktop side by side so you can view that they're actually eValid did launch 100 instances of the eValid.exe, the thin version of that.
There's this famous, I'm going to just, while we're watching this, there's a famous show about Mythbusters in the United States that shows on TV, and the guy always says, do not try this at home, as he's blowing up a car or something like that. There are some, I wanted to point out, there are some special changes that need to be made to the operating system parameters to permit 100 plus browsers. And those involve changing heap space and some other priorities. So if you try 100 plus browsers on your regular vanilla flavored out of the box version, you won't get that far. But how are we doing here?
They are still launching away in the background.
What was the wait time interval?
May have been 100 to a second in between, possibly.
Notice, everyone should notice that there's a $wait. This particular script playback is picking up from the eValid parameters. It's picking up all those values from a local environment file. So there's a common way, a relatively easy way for eValid to feed data into these scripts. Oh, now you have 100. I see 100 right there.
Okay, so now you notice on my desktop task list, there's 100
We'll bring them up.
instances of eValid, which I'll go ahead and place side by side. And there they are.
I don't see it
bring
yet.
up our launch page. Yes.
I don't see the 100 yet, but I'm watching.
There's always a little bit of a delay.
Yeah, there we are. Be prepared for a busy screen. I think this might set some new record for the busyness of a screen. Go ahead and start the playback.
I'm going to go ahead and open this one up so you can peek into what each of the 100 are doing. I'm going to go ahead and click Go. And you'll note that the test2.evs scripted files are being launched in each of the individual browsers. And as soon as they reach the 100K kilobyte file download, then they're going to just close because I had requested only an iteration of one.
Yeah. So there's the download, and then poof, that one will create a hole in the fence. And you'll see the holes in the fence disappearing as each one of the browsers gives up and returns the desktop to the natural state. I love that picture.
Okay, as soon as eValid completes the load test scenario, you're presented with a summary inside the load test scenario monitor, and that gives a summary of how each of the browser instances playback time in as slow, as fast as, an average. And then you have an overall time.
Yes. Scroll down to the bottom of that to look at the summary statistics. There we are. So there were,
Yeah, right here.
that took 3 minutes and 5 seconds to run all of those. And isn't there a fastest and slowest summary? Fastest,
Yes, right
yeah,
here
right
in the
there.
middle here. Yeah.
Well, right there in the middle, it says fastest playback time was 84 seconds and the slowest was 174 for an average of 128.
Right,
That
equivalence in color. Yeah.
Now that variation in time is due to our web server having trouble delivering that much raw data out the pipe. So we've saturated. This is chosen to be 100 kilobytes because we know that'll pretty much saturate the web server. Okay, that's very good, Whaley. Very good.
And then we have also the equivalent
Yeah.
load test chart if you want to see
Yeah.
graphically how the
Oh,
time is
yes.
speeding.
Yeah, that's good. Okay.
All right.
Okay, excellent. So give me back the screen.
Okay. Let me try to get that back to you.
Show my screen. So just to remind everybody, we did a screenshot of this and an animation because people don't always believe it, but there is the 100 browsers. I just want that to be fixed in people's memories. Okay, enough of that. Now, let me just say about the use of eValid for load testing. We specialize in imposing load. The performance monitoring capabilities of the LAMP stack and of the IIS environment, those are all more than sufficient to identify where the bottlenecks are. But there's a progression. Local XP with 3 gigabytes and a large RAM easily gets you 100 browser users. I'm speaking right here. If you want to get to 1,000, then we use 10 user accounts on a cloud image, and for 10,000 browser users, we use 10 machines each with 10 accounts. And a typical machine we're using to get 1,000 browsers is this particular example here, and we regularly do these kinds of experiments for customers where we work out the script and the customer approves them, and then we manage the creation of the load. And it's typically a session that runs several hours where you ramp up over maybe 10 or 15-minute intervals. The example we showed you was the 100-wide monitor, a 100-wide example. If you're doing multiple machines and you have multiple desktops and there's a bit of a dancing around management problem, but everything runs just fine. Okay. Thank you, Willie. That's a good demonstration. So we're at 40 minutes into the webinar, and my idea now is to tell you what it was I've told you so that you'll remember that. First off, functional testing from a record-play paradigm, low-cost way of getting a lot of recording done, fix up any synchronization problems, also at low cost. You can take that desktop safe, fully self-synchronizing AJAX application and play it back in a monitoring mode and get good performance data as if there was a real user running. Or you can take that same kind of a test and put it into a server loading mode operation where you can get hundreds or thousands or tens of thousands of browser users running all in parallel. So the assertion at the beginning of the webinar was, here's a complete QA and testing department in a box, and I think if you can see that this applies in particular to the most complicated and most difficult kinds of applications that you can have, the AJAX applications, which are really, really sophisticated, I think you can see what the intrinsic value is and what the tremendous value is of the eValid